Yep. So I'm Jonas Bonér. I'm the CEO and founder of Lightbend, and yeah, you can find some more information about me there. I'm J Bonér on Twitter and my website there. So if you want to learn more. So this is a mouthful. You know, I was sort of thinking about discussing a couple of topics that I think that's been on my mind the last years. And they sort of converge, you know, into the same vision that I've had, you know, about how I think we need to go as an industry and what I think we need to do to tackle some of the challenges we have. The first one is essentially two sections. The first one is like how I think the emerging edge, you know, edge computing, sort of calls for a sort of unified cloud-to-edge experience. You know, we need to look at it as one thing. I think everything will eventually be just the cloud that's extended to the edge. It won't be two different things, as we have said. Like, we always like to categorize things and you know, see them, put them in boxes and so on. And edge has been sort of something that's been going on for quite some time. You know, 10 years at least or so. But I think it's been a lot of work going on the last 10 years, and I know that it's really ready, and it's extremely promising, and it's something that I think we all should think about and work towards. But the second thing is more of a general problem in our industry, and that is really how to tackle all this emerging tech, all the products, you know, all the complexity that brings, because it can really be overwhelming. And I think that also calls for a unification. It calls for us like climbing up this ladder of abstraction, and look more broadly and how we can, you know, move to value faster, because we all want to, you know, we all build systems because we want to really ship working software to our customers as quickly as possible, in a predictable and all of those things. So I really think it really sort of, you know, it sort of summarizes that I really think we need to rethink and adapt in order to liberate ourselves as developers and really maximize business value. So that's what I was planning going through. First, just a definition of what edge computing, if some is new to that. You know, this is just, there are many, course, but this is just one I took from Wikipedia. Edge computing is a distributed computing paradigm that brings computation and data closer to the sources of that data. So keep that in mind. You know, the edge has been around for quite some time, as I said, and it can really be scary in a way. And it feels like we should be like approach this cliff, through this edge, and jump off. You know, there's a lot of buzzwords and jargon and a lot of hype, honestly. You know, how do you navigate that hype? You know, there's a lot of new tech, new products coming out, and of course, a lot of new things to learn, and a lot of new things to unlearn as we embark on this journey towards the edge. And once you've done that, once you've sort of integrated it, how do you compose that with existing knowledge, and even more importantly, probably existing systems? How can we bridge that to the cloud or on-prem or wherever you live today, you know, and build software today? I really think that, you know, that it doesn't have to be that scary. It can more like be like jumping off, you know, the edge of a pool, sort of diving down into the waters. It can sort of be fun, it can be refreshing, it can be empowering, and it can open up a ton of new possibilities. So hopefully you will dive into this pool with me now then. The edge is really already here. It's been here. It's been talked about for a long time, but you know, the last years I really think it's really starting to cement itself as an extremely powerful force in the industry, and they really open up a ton of new opportunities. You know, the last decade or so, the telcos have been really, you know, working a lot of extending, you know, so 5G out to the edge, for example, and that will open up a ton of new possibilities. You know, the cloud providers have been like moving what used to be centralized cloud out to the edge, you know, with small sort of edge data centers, that are actually very close to the user, all the way up to the cell towers that the telcos provide, and allow us, to bring software all the way up to the last jump before the actual device, meeting phones or tractors, or autonomous vehicles, or whatever it might be. So there's a lot of things been going on in terms of building out the infrastructure that we need to run Edge. And of course, as I said, 5G is extremely exciting, allowing more sort of localized way of deploying and communicating across, cell towers in regions, in stadium events, for example, or in like villages or wherever it is. There's a really new, interesting world that I think is emerging. And what is driving all of that then? It's the need for customers to be able to be served faster. You really need to have a way of moving data, compute, to where the end user is. These three things, I'll come back to that, they always have to be next to each other. And that's, I think, what's one of the real promising things with the Edge. And I think we're sort of moving towards a more sort of holistic view of what Edge means, thinking in terms of more stateful. The Edge have historically been more like the sort of the CDNs, like serving static data. You allow it to attach compute to that serving of the static data very close. But I think we're entering sort of a more dynamic environment where we really need to tackle, data, compute, right where the user is producing that data. And so stateful is I think, is really something that we need to think hard about. And of course, as always, there's a huge market on the rise here. You perhaps don't care, but it's been rising like from 4.6 billion in 2020. It's predicted to reach about 140 billion market cap in 2030. So there's a lot of opportunity here. And one sort of quote that resonated with me, that Gartner, in one of the papers that Gartner came out, was like, and I quote, "Edge computing is actually being implemented today in many of our clients' environments, enabling entirely new applications and data models. Simply put, Edge has moved from concept and hype into successful vertical industry implementations with general purpose platform status approaching rapidly." And this is really something that I'm hearing a lot when I'm out talking to our clients at Lightbend, building things on Akka and so on. Many are already using the Edge, but in an ad hoc fashion, stitching together a system that sometimes is not completely holistically thought through and so on. And many others want to move to the Edge, but they don't really know how. And they're all really struggling with how should they connect the Edge to the cloud. Where are the sync points, and how does it all fit together? And I think this is one of the real real challenges that we need to face. And there's really a really massive data tsunami coming. Gartner again, they predicted by 2025. That's only 2 years out now. 75% of all enterprise-generated data will be created out at the Edge and processed out at the Edge. It's really needless to capture all that data from your clients and then ship it all the way back to the cloud, do thorough processing, and then moving it back to the Edge to serve your customers with intelligent answers and analysis and so on. It's extremely wasteful. It just takes too much time, and it's just not cost efficient and energy efficient and all of these things. So, this whole movement towards the Edge really require us to keep data out at the Edge, leave it there, and do processing there. And that means that we have to think about physical co-location of data processing and end user. And the end user, in this Edge world, is extremely dynamic. It might move around. We have clients, using running autonomous vehicles, for example. The cars are actually moving around, jumping from cell tower to cell tower, and then being able to have a dynamic environment where the data can actually move as the user moves. Think mobile phones or whatever. The benefits, of course, that you're able to serve your users extremely quickly, because your data is always right there where the user is. The processing is of course right there where the user is. So faster answers. But it also means that we are able to serve our customers a lot more resilient, available. Because this means that if all these three things are always available right where the user is, everything can sort of crash and burn around you. You can lose the connection back to the cloud, and still serve your customers, which is extremely exciting, I think. So the edge means different things to different people, and there's if you ask 10 people, you probably get 10 different answers. But the way I'm thinking about it is sort of a hierarchy of layers, and here I only have 4. There's a lot in between here, of course. But to simplify things, I see it like you have the central cloud, then you have regional, then you have like near edge, often called, and then you have far edge. Far edge is like the last hop before the devices, and then you have the actual devices themselves that are like field deployed wherever they happen. It can be in tractors or cars or whatever. IoT is of course a subset of all of this, and we all know what IoT means. The big problem though is like software that is designed to run out at the edge usually don't run well at all in the cloud, and vice versa. And the reason for this is that the infrastructure requirements and the challenges are vastly different as you move, or they change vastly as you move across these layers. For example, further in towards the cloud, at the base here, you can often sort of assume 10 to thousands of nodes coordinate. You have reasonably reliable networks and hardware, running in AWS and Azure or something like that. You have vast resources and compute power. You can do like really strong consistency and strong guarantees. You can put things in a SQL database, and that's sort of have one view of the whole world in a way. If you put all the way data, that is really strongly consistent. You can make global and very thoughtful decisions, like on a wide system scale, sort of. And as you move out, towards the devices, across these layers, however, everything changes. Now you're dealing with tens or perhaps hundreds of thousands, perhaps millions of POPs. Actually, millions if you reach the actual devices, and things get more and more unreliable as you move out towards the edge. You have way more limited resources available, but some of the good things is, as I said, as you move, sort of closer to the devices, you can really start serving customers more in real time. You can serve them immediate answers, but less complete. You probably need the cloud in order to serve really complete answers, but you can give immediate answers right when you get the data. So you can actually work a lot faster in your response times and so on. And as I said, as you move out to the edge, you can actually be a lot more reliable and available, from the perspective of the user. Because as these layers start to break, which everything fails in software, on and off, you still have everything needed to serve your customers if you're out there with the right data, right where the user is. Yeah, there's more to say here, but I really think that one of the key things here is that we really need to think about each one of these layers as being autonomous. Ideally, each layer should continue to function fine, even if lower layer breaks. Continue to serve users, and if lower layers, meaning all the way to the backend cloud, is available, great. Then we can start making use of that for more holistic processing, more thorough compute, pushing things into Spark or Hadoop, God forbid, or whatever it is that you're using, to look at the world more holistically and serve your users, with this more complete picture. But we can't rely on that. It's just too costly to push everything down and up and down and up constantly. So I hope that makes sense. So why does cloud matter for businesses? Yeah, when I'm out here, when I'm out talking to customers, the 4 key things that really matter to customers are, like, of course, low latency. Speed matters. Resilience, I've already talked about that. Availability matters. Operational efficiency is another thing, being really cost efficient, resource efficient. And the fourth really key thing is data, sovereignty. Compliance matters. One of the really nice things about Edge, it gives you the way to have localized serving of data, GDPR and all of those things. Actually making sure that you are in compliance and data doesn't leak. Security is also a really big thing. As you move out to the edge, things become harder to contain in terms of security. That's also one thing that is really important. Some of the use cases that I've been running into with our clients are, just to give you a glimpse, is like autonomous vehicles, retail, e-commerce, trading systems, healthcare, emergency services, factories. Factories is a really big thing. They need to continue to constantly process, even if the churn out whatever products they're using or they're building, even if the backend cloud connection is dropped. Stadium events, being able to have localized sort of serving of your users in a box, in a way, or conferences like we have today. Gaming, another big thing. Farming, financial services, smart homes. Put everything in IoT here. And digital twin type of patterns, and these are some of the very common of the common ones. Sort of my vision with this is that we should move towards like a cloud to edge data plane, where we see cloud to edge not as distinct black and white boxes that we have to stitch together, but as a sort of continuum. That we can sort of build these location transparent services that can run anywhere. You shouldn't have to think about, okay, now I'm building a service that I should deploy to the edge. And now I'm building another service that I should deploy to the cloud, and I need to put them together. And ideally, it should not be a design decision. It should not be a development decision. It should actually not even be a deployment decision. You should build these services and then just throw them into this vast continuum and have them run wherever they optimally run right now. And that might change. As data moves around, as the application evolves over time, as your users move, etc. So really, what I want to move towards is sort of a way of having sort of data, exist wherever and whenever needed, and only for the time that is needed. Because keeping data somewhere where it's not needed for longer periods than it needed is really wasteful. That's what consumes resources. As I said again, data and compute always moves together. They're really one unit. You need to fully encapsulate data and compute and have them adaptively move as a user moves, or move them adaptively across this layer, this sort of hierarchy of layers. So this is sort of the vision that I'm working towards. And what are the sort of the technical challenges here that we need to address? And I think first we need to have autonomous, self-organizing components. And as I said, we need physical co-location of data, compute, and end user. That means that we need to have a way of looking at it as a unit, as one thing. And we need to have intelligent and adaptive placement of that. Having a way of placing it where it can best serve our use cases right now, and have that change over time. Have data move as needed. And one really interesting sort of trend is this trend around local first development. Have you heard about that? It sort of inverses the way we normally think about systems. Having that, if you have everything that you need up where the user is, then you're actually not dependent on anything further down. Local first really means that it's local. The local situation close to the local context is the primary, as I said, and everything can sort of fail down, and you don't need a constant connection to the back-end cloud to serve your customers. But if that connection is available, sure, let's use it. Let's use the vast resources down into the cloud in order to get more work done, more thorough processing and so on. And it really also needs that we need to think about the way of designing systems in a more fine-grained way, and having sort of fine-grained way of doing replication, not like table-wise, if you look at it like, but actually row-based, having adaptive event filtering so you don't ship all the events wherever if you build an event-driven system, which I really encourage, and entering this world. And having like consistency a la carte. We can't always rely on strong consistency that we've been sort of taught to use down in the cloud. That's really luxury of the cloud that you often can rely on that. Many run, of course, NoSQL databases that allows you to have more loose ways of dealing with consistency for scale and for availability. But as you move further out towards the edge, you really need to start thinking about what is the right consistency model for my data where I'm running right now. Because strong consistency is extremely expensive. It puts a cap on availability. It puts a cap on a lot of things. Scalability. The database can often be a single point of bottleneck and a single point of failure. So having ways of modeling an eventual consistency, causal consistency, and strong consistency, and having them coexist. I think this calls for options of having sort of what I call state models, or like shapes of state. All from SQL to event sourcing, to working with CRDTs is another very popular thing. Means conflict-free replicated data types. Having a way to replicate data. They allow you to replicate data in a way that is like always eventually converging to the right state. Eventually. They're eventually consistent, but they're sort of strongly consistent eventually, in a way. Having ways to model things like views. For if you use event sourcing, for example, having a way to have like view projections that are streamed, and all of these type of shapes would be very nice to have at a higher level in terms of like first-class concepts that we can work with, and of course like end-to-end guarantees of SLAs and so on as we move across all these layers. Of course, I personally rely on Akka. Akka is a framework or a platform rather today that I created in 2009, and when I created that, it was the edge was really just starting, but I always felt like Akka is based on the actor model. How many here have heard about the actor model? Okay, not everyone, but okay. The actor model is a model that was invented by Carl Hewitt in 1973, I think it was. It's quite an old model. It's really been pioneered by Erlang, and Akka was at least initially very inspired by Erlang, and I think that these actors, as we call them, they're really just services that are composed, have a way of composing state and processing into one single unit. They're really the perfect environment for the edge, because actors, as I will talk about, are really get stronger the harsher the environment is. They fit better the more things break, the more things go wrong. They're really intended for that type of environment. It's perfect for the edge, really, and it sort of encapsulates this whole idea of let it crash. That everything in the world will probably crash and burn around you, and you need to have a structured way of managing failure, not just being a victim of failure. And oops, something failed, I need to deal with it. But looking at failure as a first-class state, in your finite state machine. You have running, you might have paused, you might have resumed, you might have failed. So if you always know that failure is a known and valid state in your application or in your services lifecycle, there's nothing scary about it. Then you know exactly how to recover from it. So Actor has this built-in feature of self-healing, and they're extremely lightweight. I mean, I can easily run millions, literally millions of actors, meaning in Erlang or in Akka, on my laptop here, and they encapsulate this whole notion of being completely autonomous. I don't care about the rest of the world, really. You know, if someone wants to interact with me, fine. But I have everything I need. You know, I have the state, I have the behavior, I have a way to deal with failure, dealing with the harshness of the world outside, and I can just, you know, move around and serve, you know, my use case, you know, the way, you know, I'm intended to, and it's. You know, actors are also have this notion of being location transparent. I mean that you always have a reference to the actor, but the actor can run wherever. That means from a client perspective, I don't even know where the actor is running. It can run right in process, but it might also run out on another device. I don't know that, and that's a strength. You know, this level of indirection means that the actor running somewhere else that I have a reference to in Akka we call it the actor ref. In Erlang it's called the PID, the process ID. Since we have this level of indirection, you know, that means that the actor can actually crash and spring back into shape without the clients even knowing. So that's where we have this sort of this self-healing capability. And you know, and it allows you to serve your user with extreme low latency. It's extremely scalable, as I said. You know, you can run millions of these. And they're more like modeling how things work in nature, like with bacteria or like ants or something. There's been a lot of models, or people have been thinking about actors in that way, you know, because nature has an inherent way of self-organizing to the best behavior for the current situation, and always recover from failure. You know, reliability is of course efficient. They're extremely efficient. You know, we have many clients that had to like cut down their infrastructure costs sometimes 100x, moving from a traditional cloud system built in whatever. I won't give any names, you know, but moving to Akka. You know, you never sort of sit on resources that you don't use. You know, actors always give them up so you can multiplex on hardware the way it's you know, in the most efficient way. So you know, and Akka's been moving beyond the actor model into this whole world of distributed systems, you know, very efficiently, and it can really sort of, you know, manage distributed systems at scale. You know, where data with this world where data is always available where it's needed right now. You know, and it's always at the right place at the right time for the right duration, but nothing else. You know, if something's not needed, give it up. You know. So you don't sit on more resources, and you know, what we've been working on in Akka the last few. Let's see how I'm on time. Yeah, you know, the last couple of years is what I call Akka Edge. You know, it's sort of just an extension of Akka, but it's sort of a project name that I picked. You know, and the whole point of Akka Edge is really, you know, taking the power of actors and sort of stretching it out all the way to the actual devices. A really way of tackling this cloud to edge continuum, having one single unified programming model across all these layers, you know, and of course, you know, Akka runs really well in the cloud, and on-prem. Here you have things like, I don't know if you know Akka, but we have a lot of, it's like this rich ecosystem of libraries, you know, for HTTP, for doing streaming, for Alpaca is like an reactive integration patterns if you want to connect, you know, the world in different ways, you know, pub/sub or databases or streams or whatever it is. But we sort of also expanded it in this Akka cluster that gives a really structured way of doing hard things like cluster sharding, having a singleton in the cluster, ensuring that the resource is only in one place, you know, even on a global scale. Persistence, having a way of attaching event logging, you know, in a structured way to power your actors in a fully durable and persistent way, and having a very efficient way of doing replication. You know, we leverage vector clocks and CRDTs and all of those things. I'm happy to dive into those more, you know, offline. But what we've been working on the last year and actually shipped in May now is moving Akka up to what I call near edge. That sort of allows you to. You've always been able to do that, but having like really good tools and structured ways of taking these Akka clusters and span them out across regions, or even hybrid cloud, you know, running AWS and Azure, or spanning them across on-prem and cloud in a hybrid fashion or whatever. So you have this really powerful mechanisms like stretching out your system across whatever you want to run. It's like the next level above cloud, a little bit closer to the users, but not quite there. The thing that we've been working on the last 6 months, though, is tackling the far edge. That means, you know, putting Akka into cell towers, you know, in these edge clusters. You know, POPs can be hundreds of thousands of POPs out there, and you know, here we've been leveraging a lot of sort of reinventing and sort of rethinking about what kind of infrastructure needs you actually need as you move across these layers. You can't run Kafka out there, for example. You can't run Oracle or some of the cloud databases. You need to rethink about, you know, a way of bringing in the right infrastructure piece for the layer, but doing it at an abstraction level. That means that nothing changes for the user, meaning you. You can program with a high level abstraction and have the infrastructure, you know, being served and available to you, you know, suitable for the right layer as we move across this stack. So you know, one thing we shipped was this brokerless pub sub. This brokerless pub sub is really a super high efficient, very low latency, high throughput alternative to Kafka that doesn't allow you to run through broker. It can run in very minimized environments, you know, just running on a few megs. And of course, you know, having a way to replacing the databases is really important here. Having a way to have lightweight, fast, durable storage as we move out towards this edge. Another really important thing that we've been working on is this, you know, allowing to scale to zero. Because resources actually, unfortunately, you know, get more and more expensive as you move out. Because probably, you know, mostly because I think edge is quite new. So as you move out to the edge, you can't just sit around as we're used to with cloud and continue to consume resources. You need to have a structural way of scaling down to zero if you don't use it, and have something but have a chance of spinning it up really quickly, instantly, ideally, as requests come in. You know, and of course having ways to do like geo and use-based migration across all of these POPs that you have out there. So we're shipping that actually this month, if you're interested. And what we've been working on, you know, alongside that is actually taking this whole model of Akka connectors and moving it all the way up to the device itself. You know, the interesting here we can start leveraging things like WASM, for example, allowing Akka to become polyglot. I don't know if you know too much about Akka. You know, I don't want to make this a talk about Akka. I just want to give you some examples of how we're implementing this vision. But Akka runs on the JVM. It's available in Java and Scala only. But by moving out, you know, across these layers and in bringing in, you know, new ideas like WASM, for example, we can sort of allow Akka to run in things like this. You know, this is actually a really small gateway that runs Akka. It's a lot smaller than this. It's just like 4 times 5 centimeters. This only runs 4 megs. So instead of having to run the JVM with gigs that we're used to, you can actually run Akka now in just 4 megs. You can put this wherever, you know, in boats or cars, or tractors or whatever. But the interesting thing is here, you know, all of this is just, you know, a lot of cool technical mumbo jumbo. But from a user perspective, you know, nothing really changes. You have one single programming model across all of these. You know, that's the vision. So you have a really unified cloud to edge data plane. So you can write the services once and just throw them into this data plane, this continuum, and have them run wherever needed. You know, and some might not be ready for the edge. But then you can, you know, if you sort of adopt a model like that, you're sort of future-proof in a way. You can move to the edge whenever you feel ready. Just bring in the right infrastructure and press deploy, and it will run wherever you need. So you know, so this is something I'm super excited about. You know, this vision of a unified cloud to edge continuum. But you know, we have one really big problem to solve though, and this brings me to my second part. And you know, we all want to do more with less. We want to move like faster time to market, cost efficiency, energy efficiency. People want to do that with predictability and repeatability. and reusability, right? And today's cloud and edge infrastructure, as I said, it's great. It's really, really solid. You know, we have a ton of customers leveraging that with great success. But we're drowning in complexity with all of these things. It's really, really hard to navigate this landscape. You know, the options are just overwhelming. There's too many decisions. You know, Kelsey Hightower tweeted this. I sort of found it sort of funny, but very, very true. You know, and he said that like rolling your own platform has never been easier. All you're going to do is pick 200 items from this list, and you're good to go. I mean, who can really navigate this extreme, vast, impressive, amazing ecosystem that the CNCF provides? But I mean, picking the right products and composing them into a system that actually works is very, very hard. How can we navigate this and still move fast with predictability? Stephen O'Grady at Redmonk, you know, another analyst, you know, wrote a paper they call vertical integration, where it says that there's already too many primitives for engineers to deeply understand and manage. More arrive by the day. And even if that was not the case, there's too little upside for the overwhelming majority of organizations to select, implement, integrate, operate, and secure every last components of the service. And here comes the key part. Time spent managing enterprise infrastructure is time not spent building out your own business. Building business logic, building value for your customers. You know, who recognizes this guy, by the way? It's Linus Torvalds. You know, it's been said that this sort of the cloud is the new computer, and I think, you know, that's a fair way of looking at it. You know, but the problem though is that we are, as developers, sort of expected to still sort of hack the kernel in a way, or write device drivers. You know, meaning working at a very, very low level, and I don't think that's sustainable anymore. You know, I think we can't, like, you know, build our own computer every time. We need to think at a higher level of abstraction. You know, Alfred North Whitehead, you know, this famous philosopher, said that, you know, that civilization advances by extending the number of important operations which we can perform without thinking about them. You know, this very much applies to software development. We need to continue to climb this ladder of abstraction. I really think, or we drown in this complexity, because it gets worse and worse by the day. You know, this is Grady Booch. He tweeted this a couple of months ago. You know, that the entire history of software engineering is one of rising levels of abstraction. You know, I think we, as an industry, we've been doing really good here. You know, think about the software stack, for example. You know, going for operating systems to, you know, we have the OSI stack, we have POSIX, we have like virtualizers, hypervisors. You know, all the way to the JVM, your Erlang JVM, or some sort of runtime, up to Docker and Kubernetes. You know, all this is great stuff. We've been constantly climbing this ladder of abstraction. But it feels like when Kubernetes came out, we like, okay, this is as good as it's going to get. You know, everyone needs to be a Kubernetes expert and like start bringing all these components from the CNCF. And that's, you know, where things halted. I think we need to continue to climb this ladder of abstraction. And you know, something that resonates really with my heart, and I think is really important, is that we as developers, you know, we of course we love being in charge. We love you have everything under your fingers, you know, working with the terminals and all the things, you know. Me too, as well. But I think it's healthy to be able to allow ourselves to let go of control. We actually don't need to have every knob under our fingers. It's okay to delegate. Because, you know, if we delegate, that means that we free up our time to work with things that really matter, building core business value. Okay, you know, the last years we've sort of been moving from on-premise. You know, everything in red here is things that you need to run yourself, while things in sort of, what is that color? Let's call it blue. You know, are things that can be managed by someone else, things that you have delegated to the cloud providers and so on. So self-managed and on-prem, we had to run everything yourself, from code to frameworks to database transfer security, Kubernetes operating systems, you know, all the way down to the actual storage. In the cloud, you know, the cloud's amazing. You know, they can provide like almost half of this stack for us. You know, meaning that you have like services that run Kubernetes. Of course, like all the operating systems and the storage, there are great serverless databases you can bring in and all these things. But there's still a ton that we need to manage ourselves as developers. That's really, really hard. So, you know, the world that I like to move towards is where we, as developers, only focus on the code. You know, everything else is actually managed for us. This will really be able to liberate ourselves to just focus on the essence. And the options can really be paralyzing. I mean, who hasn't been like in a supermarket, you know, and being really paralyzed by, okay, I just want to buy some cookies, and there are like a gazillion options. It can be really be paralyzing and definitely not empowering. So I really think it's sort of three things that we should ideally only have to care about. You know, the things that sort of sit on, like, at the surface of the, sort of above the surface of the iceberg, so to speak. The design, of course, you know, the architect's responsibility, the developer's responsibility, writing the business logic, and their operating responsibility, CI/CD pipelines, the builds, and all of these things that we care about. You know, the rest, everything that should be left and remain underneath this iceberg, ideally. I won't read out all these, but you know, there's a lot more to it than what I listed here. You know, but let it remain under the ocean, and so we can really live up where we can breathe and move quickly. You know, and focus on the value. You know, this. You know, I don't know if you've heard about this concept of flow. You know, being in developer flow, but it was sort of coined by this Mihaly Csikszentmihalyi. I can't even pronounce his name. But you know, one quote from this great book is that he says, like, Cicero is one of these old-time philosophers from Greek, I think. You know, Cicero once wrote that to be completely free, one must become a slave to a set of laws. In other words, accepting limitations is liberating. You know, and Timothy Keller, you know, echoed some of this by saying that freedom is not so much the absence of restrictions, but finding the right ones. The liberating restrictions, you know, and you know, in art, it's been known for centuries that, you know, constraints liberate us, while liberties constrain us. You know, you should really watch this great talk by Runar. It's actually that's the name of this talk. It's something that really resonates with me. I'm a sort of amateur musician myself and so on. And in music, you know, we can really sort of liberate our creativity by constraining the world in a way. Like we have you know, like music keys. You know, there are modal ways of writing music. You know, you have certain chord movements and so on, constraining, you know, us from all these options that music gives us. You know, it can be liberating in terms of creativity. You know, same thing in painting. Like cubism, like in this example, is one way. You know, where the artist like locks down his sort of world in a bit in order to liberate freedom. I really think we should try to think about the same way in terms of software. How can we then find the right abstractions? What are those liberating abstractions? And I think that's really, in order to sort of distill the ultimate cloud-to-edge programming model, you know, there are, and I've been thinking a lot about this. I think there's three things that we as developers, we can never ever delegate. This is like the minimum, the baseline. You know, first, the data model, how to model the actual business data. You know, it's structured, it's constraints, it's guarantees, how do we query it in the most efficient way? The second thing is the API. You know, what I mean by that is how do I present myself to the world? How can others communicate with me? And how do I interact with the world? It can be other services in the same app or the outside world itself. And thirdly, the business logic. You can never ever delegate that. How to mine intelligence, act, and operate on that data. You know, how can you transform, downsample, trigger side effects, and all of those things, and communication patterns. How do my data flow in my application? You know, workflows, point-to-point, pub/sub, all of these things. You know, but I do think that once we nail these three things, the rest can actually be automated. It can be fully managed and automated by a platform. You know, that brings us, you know, to this world where everything is managed all the way up to the actual key things for the developers, meaning the business logic, and the API and the data model. Okay, you know, Werner Vogel is what, you know, said in I'm sure you know, and he's the CTO of Amazon or AWS. And he said in 2017, during his reInvent keynote, that he thinks, he thought in 2017 that in the future all the code you ever write will be business logic. That's a really bold statement, and I really think that's what we are going towards. We need to liberate ourselves. What if we had a world, where the only thing you had to do was actually write the business logic, test it locally in a production-like environment, feel safe, click deploy, bam, put it in container and off you go. Deploy in the cloud or out on the edge, or this edge continuum is actually, in my world, is the same thing. Well, I'll tell you, I think that the future is already here. This is what we have been working on the last 4 years. I don't want to do too much of a product pitch, but I just want to give you a little bit glimpse, at least. This is one example. There are actually many platforms out there that are trying to climb this ladder of abstraction. Of course, I know mine best. It's called Kalix. I'll just give you some insights here. It's sort of a developer path for building event-driven backend, really scalable services and APIs. It has this sort of super guardrail where most decisions are taken, so you don't stand there being completely paralyzed by the decisions, but actually sort of a guardrail approach for the 80% use case. Of course, there are 20% probably that you need to go outside of those guardrails, right? But I've always loved Prolog, for example. This is something that's been a pet peeve of mine. I really think that the world will move towards a Prolog world of environment, of programming, where things are declarative, where you define the what and not the how. And this is, some of the themes, in us building Kalix. We have infrastructure fully generated from code, sort of a full stack based on Akka, of course, but a Kubernetes database message broker that is fully managed, and there's also polyglot. You can just pick whatever language you like, Java, JavaScript, TypeScript, Scala, whatever. And the key here, is that we distinguish from the developer's responsibility, meaning your responsibility, and the platform's responsibility. And I really think that's, the key here that I think that we as an industry need to go towards. From a developer perspective, when it comes to Kalix, one example here is that you write this entity. That's like your stateful service that can run wherever. And I don't know if you can see the code here, but this is just plain Java code. It's from the Java SDK. But it's essentially just a function. You define your data model here, a customer, and a create customer record. And you have a little function, create customer, that sort of does the side effect. That's the only thing you need to do, apart from annotating declaratively what kind of shape it should have. Should it be, like in this case, an event sourcing shape? Should it be key value? Should it be the view? Should it be, whatever type of data shape? Because the data shape affects, the model that is picked then for consistency, for guarantees. That will of course match your SLAs. And so that is sort of the data model side. Then we also have something called, I won't show you, we have more components, but one really important one is, like, I think is our view components. This is like a materialized, fully streaming view. And as you can annotate that, with, for example, get mapping customer / by name. So and then we'll automatically sort of generate an API endpoint based on that. And the interesting thing is here, you can see you have sort of a query here, select star from customers where name is. It looks like a SQL statement, but you're actually operating on the data model that you define up there, the customers. You're in a way operating on your domain model and not on the actual database, because you never see the database. Because from this code, fully declarative, we sort of generate a complete stack, a fully reactive stack based on the best-in-class components, on the CNCF landscape or whatever, and ensuring that there's no OR mapping, there's no databases to be seen, there's no pub sub brokers to be seen. Everything, you just work at a very, very high level, and then you click, compile, and then bam, we generate the optimal stack for that specific service, which we might actually change depending on on the type of data shapes or data that we call them sort of, or I call them sort of shapes, you know, but how we should look and treat the data model that you have created. So here you have it, you know, the data model, your API, fully declarative, on top of your business logic, and that's everything that's needed. And I really think this is where we need to go as an industry. I encourage you to check out Kalix, but you know, there's many other interesting alternatives out there as well. So I'm running out of time a little bit, but to sum things up, I really think that cloud native and also edge is just too complex. You know, serverless is extremely promising, but it's sort of stalled a little bit. You know, we have a lot of serverless components, but you know, having a serverless database, a serverless pub sub-broker, you know, some Lambda functions, you still left to as an exercise to the developers to put it all together. And things, you know, normally breaks were, you know, in the intersection between things. And that's all on you guys, you know, especially if you need to put like security and compliance and all of those things. That's very, very hard. So we need to continue to climb the ladder of abstraction, allow us to work on a declarative programming model, I think a unified declarative programming model that can sort of liberate us as developers, you know, and this whole trend, you know, I didn't invent this term, you know, infrastructure inferred from code is something that is really starting to be popularized in the industry. But taking serverless to the next step, at yet another step, you know, on higher level, and just as a way to liberate developers. And this emerging edge, you know, forces us, I think, to think about. It's just an extension of the cloud. I think it will all be called cloud in a few years. You know, we need to look at it as a continuum with many different layers. And of course, we need to have one way of programming this whole. We can't have multiple different ones depending on each layer. We need to have a unified way. And the only way of doing that, unifying all the different abstractions across all these layers, sort of unifying all these different sort of changes in terms of infrastructure requirements across all these layers, requires us to work at a higher level. And the interesting thing is that the more constrained things are up here, the easier it is for the platform to optimize things, because the less weird things, so to speak, the developer can do, the more beaten the path is. That liberates the platform for scale, for resilience, for efficiency, for replication, and all of these things. So by letting go and not being in control of every node, we can actually empower both sides. We as developers building code, and you know, the platform is liberated to maximize, you know, the runtime sort of characteristics of the app. And we're sort of working on it. I'm giving a couple of glimpses of Kalix and Akka. So that was everything I had. Sorry, I ran 4 minutes over time, 3 minutes over time. So thanks.
Thank you. Thanks for joining us.